how do you, okay, there, go.
Good evening, class. I hope you're all doing very well, not too tired. I know this is a 4-hour class and you probably just want to slam your head down on your desk and sleep, or you just want to go home. But sadly, one student in your class decided to do at least 10-minute presentation today on his learning experience, so you're stuck here for a while with me. And I'm going to make my best, I'm going to do my best to make this interesting for you. And this is where the ironic part comes in, because what I learned for the past 10 weeks, math. And I can see on your faces the looks of terror. What? This man is going to talk, he's going to do math for 10 minutes on the board? What? No way, right? What a nerd. Well, yes, I'm a nerd. I love math. This is why I picked this subject. I'm an entitled nerd. But no, I won't be teaching math on the board for 10 minutes because we're in a humanities class. I'm going to be talking about my journey through this book, right? Every single page of this book, I'm just kidding. I only read the first 3 chapters, or tried to. We'll get at that. And, well, there were a lot of interesting things I learned during this journey. So, well, we have to go to the beginning. Secondary 5. I had a wonderful, wonderful math teacher, and he improved, like he expanded my love for math, which was already existing, and I didn't believe it, right? I already loved math so much, how could I love it even more? And well, guess what? I guess it happened. And in the back of his class, he had a bookcase about this big, and there were all sorts of random books, like not just math. There were macroeconomics, like books about cooking, English, French literature, and there was this book. And did I go out there in the back and take this book and say to myself, oh yeah, I'm gonna read this, I'm very interested in math? No, I had other things to do. I was talking to friends and things like that. But apparently my English teacher in secondary 5 thought it was a great idea to have a reading period where you had to bring a book to class to read in Sec 5. I'm definitely not going to be lazy and bring a book from home to read in class, right? Right? So this is where the book comes on my desk, and I'm out here, right, looking at the English teacher, and yeah, I'm 100% understanding what is in this page, random page of the book. I'm having fun. And once again, I'm lazy, so when the English classes are done, I just leave it on the side of my desk, and I don't touch it. And I'm not bringing it back to my bookcase, right? I'm just leaving it here. And as time passes, it starts catching my eye a little bit, right? Because it's always on my desk. And so I open the first page, and I read the words, and I'm like, wait a minute, I understand this. This is high school stuff, right? If I go a little bit further, maybe I'll learn something new. I love math, why shouldn't I do this, right? It's fun. So I read a couple of pages, and then I close the book, and I don't touch it again for the rest of the year, because I found it fun only for a little bit, but final exams were coming. And when I was packing my stuff to bring it back home, and I saw the book once again on my desk, I thought to myself, well, maybe I could ask the math teacher. Maybe I could keep it, right? Read it during summer, because I'm definitely going to read this during summer. Summertime, I asked the teacher, can I bring the book home? Can I borrow it? He's sure. Nobody's going to go to the bookshelf and be like, somebody stole the elementary calculus book. No. So I took it back home, and obviously it ended up in the corner, picking up dust for the entirety of it. I only opened this book the 3rd week our teacher gave the assignment. So it took me 3 weeks to finally decide to touch this book, to finally open it. And when I finally decided to touch it, open the fabled book, I asked myself, why? Why did it take me so long? I said I love math. I've said it like 15 times now. I love math, right? Why did I only open it then? Why did I not open it in summer? Can somebody give me a random explanation? Something? You can just talk. Why would I not touch it during the summer, but then finally, when I have this assignment, and I've decided to touch this book, I start finally reading it. Oh, you're all too,
because it's too nice outside, and you just want to go outside and play.
Right. Well, that's a big, big key part, right? Doing other things. Maybe not going outside, because I'm a nerd, I stay inside and I play video games. But I do other things, right? Not this. This is, sure, I may be a little bit interested in this, but there are a lot more interesting things to do in summer. Why would I do this? And then, beginning of the year, I decide to learn this, and there's a deadline suddenly, and I'm getting kicked in the butt. Do it, read the book. The key word in this part, the first key moment, it's motivation. So, you did not give me the
Yeah,
pencils.
they're right.
Oh, yeah?
Oh, they're right there on the left.
All right.
Yeah, there's like.
Thank you. So, motivation. This is not to get into the 10-minute mark. Don't worry about it.
We're already halfway
So,
there.
I have done my research a little bit on motivation, and turns out there's special terminology on motivation. So, scientifically, from the intrinsic motivation theory from Santos Longhurst, his article, there are apparently two types of motivation, right, that makes us do things. There's intrinsic motivation and extrinsic motivation, right? So, what is the difference between them? Intrinsic, inside, we do it because we love it, right? We want to do this, and it's personal gratification. You like it, right? You enjoy it, and you feel reward for doing this. Extrinsic motivation, from the outside. You need to earn money, so you go and do the job. You're motivated to go work because you need the money to have some fun with friends at a bar or whatever, right? That's extrinsic. Or, for some reason, you have a deadline at school, and then suddenly you have this urge to finally do your work. So, going back to my example, during the summer, what was active? Was there any extrinsic motivation going on? No. Was there a bit of intrinsic motivation? I mean, a little bit, right? I do say I like math, but there were a lot more things that, well, and were way higher in intrinsic motivation, so it got overruled, and I never touched it. Now that I have deadlines and I have to get information from the book, actually do something, suddenly I have some of this too, and the both of them combine and work together. And now I'm working on this. And so I'm here today doing this presentation with all this interesting information, right? And another important part right here, now we're gonna make a connection with our course we learn, is all about self-learning. We, as students in the banking system, have never done something by ourselves, have never learned something by ourselves at school. We have been taught, we have been said, we have been spoon-fed our information, and then we just spit it back out on exams. We have never been given this much freedom, or at least partial freedom, to learn our things, right? And plus, I'm learning math. I'm not learning cooking, right? Once I'm done with this project, next week I'm not gonna think to myself, oh, maybe I'll cook something for myself, right? Because it tastes good. I'm not gonna go over this book and reopen it and be like, okay, let's continue this, right? Why not? I'm not gonna do that. It's math, it's a school subject. Why would I continue this, right? Why would I be motivated to learn this in the end if there is no reward except doing something that's maybe fun on the inside? So it takes a lot of motivation to finally decide to learn something by myself. As a matter of fact, if there wasn't this project, this book would have ended up, I don't know, in my fireplace at some point. But now I actually opened it. And so my journey began. So what I just told you right here, this is my first key moment when I began my project. So I started flipping through the pages, and I followed a bunch of strategies that we learned during the first part of the semester in this class, right? So I didn't do too many chapters every day, maximum one, two chapters, because if not, then my brain is gonna go crazy. Sure, I love math, but I don't love math that much to keep on reading like 10 chapters in a day. So I read one or two, and I made sure I understood the theorem as I read them again and again and again. So I went on and I did the exercises as well. I kept on verifying that I was correct at the end, because yes, there are the answers at the end, or else it would be pointless to do the exercises in the book. So I did them, and everything was going great. And then the new information, the juicy part came in, things I have never seen before, right? And that's, we're going to my second part, my second key moment. I started learning new things called hyperreal numbers. For those who is taking a calculus class or has taken a calculus class, who knows what hyperreal numbers are? We're gonna get to that. So I was having fun with hyperreal numbers, and some exercises were going great. I had to go slower, however, right? I had to go slower, and I began talking to my other friends, because this is another strategy to remember things, right? You're getting your information back out of your brain that you read. Like you read it, storage strength, then you're working on your retrieval strength. You're talking about other people. When I finished reading my chapters, I closed the book, and 5 minutes later, I try to remember what I read, because this is really important stuff. The revision was easy. I already mastered those things. This, I did not master this. I had to make sure I really knew what was going on. So I really did my best to employ the strategies. And then at some point, I went on an exercise, I looked at it, I tried to solve it, approach it from different angles all the time. Nothing, I couldn't solve it. This was my first exercise I was not able to solve. And I got frustrated, and it only made me blinder. I couldn't see anything, right? There was no way I would solve that problem. So I decided to go to my architectural mathematics teacher. In architectural mathematics, we don't do calculus, but she did say at some point that she did teach calculus. And I was happy, right? Maybe I'd finally get the answer. And I showed her the exercise on the book. I was like, can you help me? And she looked at it for 5 seconds, and then she was like, what is this? I don't understand. What? How come a calculus teacher can't answer a question from the elementary calculus book? That doesn't make any sense, right? Right? Well, the thing is, I started doing researches on the internet. I thought, well, I don't know, maybe it's the fact that the book was written in 1976 and that the way we teach calculus has changed. Nope, nothing came up about that. We still teach calculus the same way. The thing is, though, at some point, I came across a Reddit post, and there were people talking, and apparently, there are multiple ways of learning calculus. What? There are multiple approaches to learning calculus, which is pretty crazy. You guys, when you were introduced to derivatives, you were talking about limits and with the x and the arrow. I didn't see that, right? I learned this with this and not this. And the thing is, when they were discussing, they said that both of them had advantages, right? Limits were more intuitive, but hyperreals for some were more exhaustive, which is pretty crazy, right? But this we can make a nice link with our humanities class with history. It sounds weird, but what would have happened if history was taught by indigenous people? How do Americans teach Canadian history versus how we teach ourselves Canadian history, how our teachers, right? Everybody has his own approach, but in the end, we come to the same thing. Each and every one of them has its advantages, while it also has its disadvantages, right? So there are always multiple approaches to learning. And the second part of this key moment that really struck me is, well, the fact that the teacher couldn't answer my question. Well, in the end, you realize simply that, well, it did not, okay, there we go. So, teachers, right? Teachers were students once. They learn from other teachers, right? And we can go on and on and on. So the thing is, the teachers end up teaching what they were taught, right? And thus, it is evident that this teacher did not learn the hyperreal numbers. Everybody has its own way of learning, and this is context. Content is never devoid of context. Every teacher has had his experiences, and he built on those to teach again. So we have this big line with student who becomes teacher, and then he teaches students who decide to become teachers, and there's this whole loop, and this is how we came today, right, in the banking system. All right, this was key moment number 2, hyperreal numbers. Y'all are looking kind of a little bit tired. I'm sorry for the y'all expression, but we're gonna keep on going. So I finished the hyperreal numbers, and I finally get to the coolest part, derivatives. I'm going to explain what derivatives are later. It's not going to take long. I'm not going to teach a full-blown math class, but I still have to explain it. So I learned how to find derivatives, and then there's this friend of mine who texts me, and she's telling me that, well, she's been having trouble with a physics assignment that she had. It was online, and they had to answer questions, but if they were wrong, they didn't know on which question they were wrong, so they had to look back at everything. And she had 10 on 14. She had trouble finding the answers. And because I'm a nerd, I love math. Well, I love physics as well, obviously. And I have time to lose with 8 courses during this semester. So I decided, okay, let's just look over the questions. Maybe I'll find where mistakes could be. And I come across something like this. For those who have taken physics class, most of you, this is the position of a ball in function of time. Can't see. Well, now you can see.
Oh my god, thank you.
All right, so this is the position of a ball during time, and they wanted to know the velocity of the ball at this point, and this point, and this point. And there is a really long way with formulas that is taught in physics, right? And this is how they were supposed to do it, because they didn't learn derivatives at that time yet either. But the thing is, I recalled something that happened in secondary 5 when our physics teacher was looking at these problems and he was shaking his head and he was telling us, if you guys had derivatives, this would be so much simpler. And it started working in my brain. I was like, wait a moment, maybe I can use this, right? I can use my useless math learning for something. And so I found the derivative of this, and it actually worked. So not only does this prove that hyperreal numbers work just as well as limits, but I actually helped someone. And this really made me feel great inside. And it boosted this intrinsic motivation, personal gratification. I was happy, right? And this motivates me to keep on going. This is my third key moment. I'm sorry, I'm not really following my PowerPoint. This is the surprise. Okay, so there we go. This is absolutely great. And finally, we're going to my last key moment, where I kept on going on my book, and I was more motivated than ever to learn, right after that great experience. And so I kept on reading, and I came across a page which taught us a new theorem, and I was so blown out of my mind. This was the biggest moment, okay, the biggest moment of my learning experience. And I'm going to make an analogy here. So, let's say you're peeling potatoes with a knife, and you're holding the potato in your hand. So you have done this so many times that you know how the blade works. You know how thin you must cut the potato. You know the technique. You have mastered this. You understand how you're peeling a potato. This is simple. This is a bit dumb. But then imagine there's your friend who comes in with his potato peeler machine and he dumps it here. He dumps a potato in and it just peels like this. Does he understand how to peel a potato? No. But can he do it more efficiently than you? Yes. So, what does this have to do with derivatives? We'll get there. Okay, this is the math part. Please guys, don't get too bored. Well, you can sleep, I don't mind. But I'm still doing this math, okay? So, to understand a derivative, let's say you have this function. Definition of a derivative is it's a slope. Yes?
It's the slope of the tangent line at any x function.
Wow, you learned calculus.
I am taking calculus.
I am not going to go this far. It's just, don't forget that I'm doing this with hyperreal numbers, so it's going to be different. Okay. So the definition of a slope is delta x on delta y on delta x. We have learned this in high school. This is value of a slope. So if we want to find a slope for a very particular point, well, see, it's this part here. If I were to zoom in a lot, this is right here, the line would be so stretched out that it's straight. And if I wanted to find the value of this slope, I'd simply have to find the change in y with this change in x right here. And this is x plus the small change, y plus the small change. The y might be negative here because it's going downwards. Don't worry about it. Okay, so you see, so you're finding here this variation to find the slope, but here you're zooming in so much, so these are so small. This is the part of the hyperreal numbers. It's an infinitesimal number. It is, you can make the link with limits, right? It's a number that is infinitely close to zero. It is so small that when you're gonna find this, right, it's gonna be so close to the actual line that has not had this modification that it doesn't matter. It comes back to the same point. So what we have to do is we have to take this function and find its derivative with the usage of the variation in x and y. And now I'm going to do some math. And okay, so I want to find the derivative of, let's say, 2x squared.
I know the answer.
So this is equals to y. Okay, I know. Wait. Just wait. I have to do the long way first. This is the fun in this part. Okay, so I want to find this part. What is the definition of a derivative? It's a slope. It's a delta y on delta x. So I come from this point, and then I do this point, so I have okay, I want this, so I'm going to move the y over here. it's not very pretty, but we have this first part right here. So I'm going to remove the y and we're going to replace it with 2x squared. Now, we're going to expand this. It's squared. We can expand it. This is algebra, very basic algebra. So 2 times okay, so then you'd apply the 2 here and we instantly notice that the x squares are going to cancel each other out, right? So then you'd have delta y equals 4x delta x plus delta x squared. And now some people are starting to be like, okay, yeah, I know where this is going. I have learned calculus, but okay, let's remember that this is a definition of a derivative. So now we're going to divide by x on both sides. Delta x, not x. 4x delta x plus delta x squared divided by delta x. So these would cancel each other out, and the squared would cancel each other out. So in the end, you'd have delta y over delta x is equal to 4x plus delta x. And what I've told you before, what is the infinitely small hyperreal number? This thing, it's extremely, extremely small. It doesn't matter. You can just remove it. And so we found the derivative, right? Now,
I'm confused about something. If you can't cancel out the delta x because there's an addition.
well, okay, so this is equal to delta x, 4x delta x plus delta x squared over delta x. Are you going to agree with me that this is 4x delta x over delta x plus delta x squared over delta x?
Yes.
See, and now you can cancel.
Okay.
Good. You're not going to destroy my thing. I learned my math in this book. I'm not going to fail during the... Okay. No. So we have found the derivative. Now what if I told you, and the guys who have learned calculus already know this, there's a much, 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 much easier way to do this. Multiply the constant with the exponent, 4, then you put the variable, and then you just take your exponent and you remove 1. This is 1, which comes back to this, and this is the same thing. Look at how long this took me. Look at how long this took. The potato peeler, the potato machine. What would have happened, right, if we were learning calculus and we were just giving you the formula to find this, which have understood how derivatives work, which have been able to picture it here, which have been able to understand how we came to find this. And there is another more complicated process to explain why the formula works, but I'm not going to do this.
The H?
This is, if you haven't noticed, this is the H.
Yeah.
Okay, so, it would, right? We wouldn't have understood anything, we just gave the formula. So it's the same thing, right? We can make a link with critical pedagogy to this. The difference between the problem posing methods of teaching and the banking system methods of teaching, where we just force you to learn things by heart and not critically reflect on what you understand. Do you understand the structure behind what you're learning in class or not? This is the same thing. Did you understand the structure behind all of the things to come to your formula, or did you just take the formula and get it out and get your answers out? What happens in real life if you have something else, right? If you have a new situation where your formula isn't going to work and you're not going to be able to reflect because you didn't understand the structure behind what you learned. Now this is the real interesting part of my final key moment. And my PowerPoint really is useless. All right, so that was key moment number 4. And now what? I have learned this, and it was so satisfying to finally understand this and reflect upon this. So what's next? Well, the answer, nothing. Nothing. I stopped reading. I never touched the book again. I don't know why. I'm still thinking about it, but maybe it has to do with what we just learned about, partly about illusion of knowledge. Maybe I'm thinking to myself, oh, I learned this, I understood this, I don't need to go further. I know my derivatives, right? I'm as good as you guys in calculus now, after having read it 50 pages in this, right? Oh, I didn't touch integrals, but yes, I do know my calculus. So that could be partly of it. Another part could be my midterms, which came in and, well, took quite some of my time, and then it kept on piling, and no, I'm just kidding, I'm over dramatizing. You know what? In the end, I think the most simple answer is I'm a lazy man. Thank you for listening.